Hello all. This is the usual walk through a past paper, and this is Unit 5 from January 2023, okay? And there will be a twist though, okay? So in this twist, I decided to walk you through the solutions as we do usually, okay? So I have the test here in front of me and the solutions, my solutions next to me. But we will also, as you can see in your window, I have my browser open to ChatGPT. Okay, that's my account in ChatGPT, and I have the paper open in another browser window, as you can see. So we will also do something like a ChatGPT versus a physicist test. Okay, something like that. So what we will do is that we will normally go through the questions. I'm going to provide the answer, and then we will take a screenshot of each question. I don't know if you ever did that, but ChatGPT is really good in reading images. Okay, so you can paste an image, and it can usually read the text from that image. But I've heard that actually DeepSeek, yeah, the Chinese model is better in that. But I don't know. I don't have that. I don't have an account with DeepSeek. So okay. What else should you know? Oh, I'm gonna be using ChatGPT 4.1 because I believe that's the openly available model. I mean, people can get that for free if I'm not mistaken. Because, okay, I can use ChatGPT 5.1, which is the most recent one, but that model is not available for free. So I'm gonna be using this one because it's free. And yeah, the other thing I want to say is that, guys, please try to go through the solutions yourselves. Don't use AI, at least not immediately, okay? Unless you run into really deep trouble. But I don't know. I was just curious to see how good ChatGPT is in solving an A-level physics paper. So the claim with AI is that we are currently approaching models that will be as good as PhD level physicists, mathematicians, political scientists, you name it, graduates. So the models will replace me. So, but anyway, let's put it to the test and see how it goes. So let's start with the paper and let's just jump straight in. So section A consists of 10 multiple choice questions. So let's start with the first one. So a student used a detector and counter to measure the background radiation count for 5 minutes. He used this value to calculate the background count rate. Which of the following will increase the accuracy of the student's value for the background count rate? Option A, decrease the counting time to 1 minute. That is absolutely not what you want to do. B, increase the counting time to 10 minutes. Yes, this sounds correct. Let's read the other ones though. Repeat the count with a different detector and calculate the mean value. That's not going to do much. Repeat the count in a different location and calculate the mean value. That's wrong because you need to take the information for the location you are in. So that doesn't make any sense. So B is the correct answer. All right, the moment of truth. Let's go to ChatGPT. Okay, actually, let's go to the test. I'm using a Mac, so if you press Command, Shift, and the number 4, this cursor appears, this cross, and you can take a screenshot of that thing. Okay, you can take a screenshot of anything you want. Okay, so let's set this aside and let's tell ChatGPT, hi, ChatGPT, I want you to help me walk through the Unit 5 past paper from Edexcel, okay, A-level physics. The test is from January 2023. Okay, I will be providing you with screenshots that include the question, screenshots, okay, that include the question, and you should provide the answer along with some brief reasoning. Okay, so let's start with that. And yeah, here, okay, the first question is attached. Okay, and let's attach it. Add photos and files. Okay, so we attached it. Let's see. Okay, enter. Absolutely, I'd be happy to help you walk through the Edexcel, blah, blah, blah. Let's start with question 1. Okay, answer and reasoning. A, B, C, D. Correct answer, B. Increase the counting rate to 10 minutes. Okay, it got it correct. Wow. Okay. Question 2. Let's go back to the iPad. Okay. So a cylinder contains a mixture of gas X and gas Y. The mean kinetic energy of the molecules of gas X is Ex, and the mean kinetic energy of the molecules of gas Y is Ey. The molecules of gas X have twice the mass of the molecules of gas Y. Which of the following equations is correct? Okay, this is kind of a trick question because you have to remember that what's the question again? The mean kinetic energy, okay? So the mean kinetic energy of a molecule is 3/2 kT, right? So let me see. So it does not depend on the mass of the molecules, okay? The velocity does depend because the velocity is, this is equal to 1/2 m, and then the average velocity squared, but they are not asking us about that. So actually it's equal, okay? So Ex is equal to Ey, and the correct answer is B, okay? All right. Let's see what ChatGPT says. Let's take the screenshot, okay? Let's go to the window and let's just throw the question. So let's say question 2. Okay, enter. So will it get B? The moment of truth. The answer is B. Okay, so ChatGPT is correct again. Should we keep a count somewhere? Maybe I should write, I should use a red color, okay? Okay, I'm doing this a little bit candid style. So, okay, I'm gonna put a tick mark every time ChatGPT gets the gets the question correct, okay? Now, let's go to question 3. The fusion of nuclei of iron-56 in a star does not release energy. Which of the following is a reason for this? Okay, it has to do with the binding energy per nucleon, probably. So, A, the magnitude of nuclear binding energy is the least for iron-56. No. The magnitude of nuclear binding energy is the greatest. No, because the binding energy increases with the number of nucleons in a nucleus. Okay, so the maximum binding energy will be for some really heavy nucleus. So no. Option C, the magnitude of binding energy per nucleon is the least for iron-56, which is totally the opposite. So D is the correct answer. The magnitude of binding energy per nucleon is the greatest. Okay. And remember this graph. So if you plot the binding energy per nucleon versus the number of nucleons, okay, it looks like this. Okay, and the peak point, okay, I'm gonna use green, not red. I was tempted to use red, but we agreed we're gonna use that for ChatGPT. Okay, so the maximum is for iron-56. So that guy over there is iron-56. Okay, right. ChatGPT now. Let's take the screenshot. Okay, let's go there, throw it in there, and say question 3. Okay, the answer should be D. Okay, let's see. Will it get it correct? A, B, C, D. Correct answer, D. Okay, correct again. By the way, let me read the reasoning because I'm going a little bit fast. So, restated question, the fusion of nuclei of iron 56 is in a star does not release energy. Okay, which of the following is a reason for this? Physics reasoning. Nuclear binding energy per nucleon indicates how tightly nucleons are bound together. That's correct. Fusion releases energy only if the resulting nucleus has a higher binding energy per nucleon than the starting nuclei. That's correct. Iron 56 is the most stable nucleus. It has the highest binding energy per nucleon of all nuclei, which is what we just said, so correct. Fusing iron cannot release energy because no nucleus has a greater binding energy per nucleon than iron 56. That's correct as well. So yeah, wow. Okay, I actually never tested this, so no, that's a lie. I did test it with out of curiosity, like I threw a screenshot a couple of times with questions that I had trouble with. I mean, okay, physics PhDs also have trouble with physics questions. Okay, it's not a privilege of students. Okay, but I never really tested it like we are doing today. So that's so things are crazy, guys, with AI. Okay, question 4. A student measured the temperature of 0.015 kilograms of wax as it cooled and changed state from a liquid to a solid. Okay. Energy was transferred from the wax to the surroundings at a rate of 25 watts. Okay. The temperature of the wax varied with time as shown. Okay. Which of the following expressions gives a value for the specific latent heat capacity of wax? Okay. Let's start with here, with this statement. So power, we know that power is energy transferred over time, right? So energy is power times time. Okay. Do they give us the time? They do. Yeah, we have the graph. So sorry about that. All right. So now this energy is transferred to wax, and it makes it okay, from a liquid to a solid energy. Okay. So this is m times the mass of the wax times the latent heat. Okay. Okay. So L must be power times time over the mass. Okay. So in the denominator we have to have 0.015. Okay. And then in the numerator, so 50 times the time, which is 100 seconds, okay, when it's solidified, over 0.015. Okay, so the only possible answer here, wait, the power is, I don't know why I said 50, it's 25, sorry. So the answer is A. Okay, yeah, okay. Let's test our beloved ChatGPT. Okay, let's screenshot question 4. Okay, let's throw it into the machine. So question 4, I call it a machine, but it really is a model. Okay, since you guys are mostly A-level physics students, so high school students are watching these videos probably. But okay, the idea is that an AI model is really just a machine that predicts the most probable next word. Okay, this is what it is, and it's a bunch of mathematics pretty much. Okay, okay, let's leave it there because you need to know a little bit of linear algebra and such. So, and I'm not specializing in AI and especially natural language processing. So, anyway, let's present her. We are expecting A. Will we get it? So the correct answer is A. Okay, another correct answer. Okay, 4 out of 4 for ChatGPT. Now, question 5. Absorption lines in the spectrum of light from a star are shifted to higher frequencies than the same lines viewed from a source on Earth. Okay. Which of the following can be concluded from this? So, let me remind you that the speed of light is equal to the wavelength times, actually the speed of any electromagnetic radiation, actually, okay? But okay, let's call it the speed of light. So the speed of light is equal to the wavelength times the frequency. So if we solve for the wavelength, we see that it's inversely proportional to the frequency. So if the frequency is increasing, then lambda decreases. So it shifts towards the blue, right? Towards the blue part of the spectrum, okay? So why is that? Because the wavelength of red light is about 700 nanometers, whereas the wavelength of blue light is 400 nanometers, lower than the red, okay? So blue has higher frequency. So this is a blue shift. So we automatically know that the star is moving towards us. So the correct answer should be D. Okay. And by the way, I mentioned this a couple of times in previous videos. When you go through the multiple choice section of the A-level test, you can usually eliminate some answers that are erroneously wrong. So for example, in this problem, A and B are totally wrong because we don't talk at all about acceleration of stars and such and things like that in A-level physics. So A and B are automatically wrong. So the only possible answers are C and D. So even if you just guess, you have 50% chances of getting it right. So anyway, back to ChatGPT. This is question 5. So I'm sorry, because of the ChatGPT part, this video is going to take a little bit longer than usual, but okay, we will do it anyway. So okay, question 5. Let's tackle question 5. Restated question, absorption lines, blah, 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 blah. Okay, physics reasoning, Doppler effect for light. Okay, that's correct. Moving towards observer, moving, okay. So D, okay, got it correctly. It's crazy. By the way, I have a feeling that at the end of this video, maybe I should be, let's see. Can you do share? Copy link. So, okay, I never tried this before, but I was thinking that, no, okay. So maybe at the end, I'm gonna copy this link, okay, and have it in the description of the video so you guys can test ChatGPT and you can read the answers and so on. So yeah, I'm gonna provide that link. So let's move on. Question 6. When a nucleus of americium emits an alpha particle, the energy released is 5.64 MeVs. Which of the following expressions gives the decrease in mass in kilograms of the nucleus when it emits an alpha particle? Okay, so this is a straightforward application of Einstein's mc squared. So delta E should be equal to delta mc squared, right? So delta m, we are solving for delta m because this is what they ask. So delta m is delta E over c squared. Delta E is 5.64, but we need to convert to joules, okay? So 5.64 MeVs, we have to multiply with 10 to the 6 because it's MeVs. So 1 MeV is 10 to the 6 EVs, and then 1 EV is 1.6 times, oops. And I promise that I'm gonna make better letters in the future, and I still write crabby letters. I'm sorry, guys. So I promise to improve my handwriting, that is. So 1 EV is 1.6 times 10 to the negative 19 joules. Okay, so we have to multiply with 1.6 times 10 to the negative 19. And then we have to divide by 3 times 10 to the 8 squared, which is the speed of light. So again, you see here that even without doing anything immediately, you know that this option and this option and this option are wrong because they include a bunch of junk in the denominator. So the correct answer is A. Okay, Let's go to our friend, ChatGPT. Okay. By the way, I feel like, we haven't, okay. So you know how in dystopian movies like Blade Runner and Ex Machina and stuff like that, they discuss the concept of intelligent artificial life and artificial intelligence and these kind of things. So it just hit me that we didn't ask ChatGPT for consent to be recorded. Okay. So, okay. Anyway, let's. I'm being silly. Let's throw the question into the model. So we expect A. Let's see. It started correctly, okay. It started strong. Delta M is E over C squared. It converted things correctly. So A, okay, crazy. So another correct answer for ChatGPT. So 6 out of 6. Right. Okay, question 7. A student investigated the absorption of gamma radiation by lead as shown. With no absorber, the intensity of radiation was I naught. With an absorber of thickness 0.8 centimeters, the intensity was 0.25 I naught. What thickness of absorber will give an intensity of 0.5 I naught? Okay, this is a new thing that was added to A-level physics, and it's actually from unit 6, but the intensity of radiation that passes, so the intensity of radiation here, the one that passes, is equal to I naught e to the minus mu times x, okay? Where I naught is the intensity as, this is I naught because the gamma source is this one, okay, I'm sorry. And, okay, let me make better handwriting. So I naught is the radiation that exits the gamma source, and I is what passes after the absorber, okay? And this is the formula. And in this case, it's our life is kind of easy because it's 0.4, okay? And the reason is that if we use more material, less radiation will go through, so that's definitely wrong. But if we use 0.2 centimeters, that's too thin of a material and a lot of initial radiation will go through. Okay, so the correct answer is B. And I guess I don't have a better way of explaining it, so let's see if ChatGPT does. Okay, let's paste, let's take the screenshot, throw it into the machine, and press the enter. Okay, let's see. Okay, so the absorption of gamma radiation follows an exponential law, and okay, and it is identified correctly. Mu is the absorption coefficient. Okay, step 1, find mu using the data given that, blah, 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 take a ln on both sides. So mu is 1.73. Okay, this is something we didn't do. So, okay, it takes the textbook approach. Okay, that's cool. And okay, this is, we can calculate that. We could have calculated it, but we didn't, okay. So set, okay, take a ln. So x is 0.4. So B, okay, it got it correctly by actually doing the math that we didn't do. I mean, we did it a little bit qualitatively. So anyway, let's go on. Let's move on. Question 8. The Hertzsprung-Russell diagrams W, X, Y, and Z below show a star cluster at various times when the star cluster is in different stages of evolution. Okay. Which of the diagram represents the cluster in the final stage of evolution? Okay. Option A, W. Okay, so this one. As there are white dwarf stars and red giants in the cluster. Okay, these are the white dwarfs and the red giants. Okay, but what is this now? I don't know. So, okay, let's move on. It sounds okay, but yeah, something bothers me with option A. Okay, option B, X, as there are red giants and no white dwarfs in the cluster. That's totally wrong because the last stages of evolution, we will have many white dwarfs, right? and actually not a lot of red giants, so this is wrong. And actually, now that I think about it, this is wrong too, because we wouldn't have red giants in the final stages of evolution. We will have just some long-lived stars of low mass and low luminosity, and many white dwarfs. Okay, option C, Y, okay, so this one, Y, as there are white dwarf stars but no red giants in the cluster. Okay, that sounds plausible. And okay, D looks totally wrong because it's only main sequence stars, so that doesn't make any sense. So that's actually a young, I mean, diagram Z will be like a young cluster of stars, so C is the correct answer. Okay, and this, okay. So this gives me the chance to test ChatGPT 2 different ways, okay? So if we give it a screenshot that includes these answers, it should be able to figure it out, because remember, this is a large language model, meaning that it specializes in analyzing text. Okay, so let's just give it the diagrams. Okay, let's be a little bit evil and give it just the diagrams. Okay, and see if it can read diagrams. So it should give us diagram Y. Okay, so question 8. This only includes the diagrams. Okay, let's see. Great, you've uploaded the diagrams for question 8. To answer this question fully, I need to see the actual multiple choice questions and answer options, as these diagrams alone just show possible stages of a star cluster's HR diagram. Could you please upload or type the rest of question 8? Okay, let me go here. Can I edit this? No. Okay, let's copy. No, please tell me which diagram is the correct one, please. Okay, let's see. It rebelled, sure. Even without the exact question wording, I can explain what each Hertzsprung-Russell diagram shows and which stage of star cluster evolution it represents. This is a classic question where you are usually asked which diagram shows the youngest, oldest cluster, or to identify stages of evolution. HR diagrams basics, okay, it gives us some mini lecture there. Main sequence and diagonal band from top left to bottom right. Okay, analysis of the diagrams, X, okay, summary. So if asked, which diagram shows the stage where massive stars have just evolved off the main diagram Z? Oh, we didn't give it the question. I'm sorry, guys. Okay, so, okay, let's give it the question without the options. So, okay. Sorry for wasting your time. I'm playing with the model too. Perfect. The question is clear. Okay, final answer. Diagram Y. Okay, it got it correctly. Wow. All right. So it can read images as well as text. I mean, I already told you that, but it's cool to actually test it. And okay. Shall we give it... No, let's move on. Okay. Wow. Question 9. An object oscillates with simple harmonic motion. The period of oscillation is 0.65 seconds and the amplitude is 0.12 meters. Which of the following expression gives the maximum velocity of the object? Okay, so Vmax, oops, I kept the red color from ChatGPT. So Vmax is omega times the amplitude, so 2 pi times the amplitude over the period. So 2 pi times 0.12, okay, over 0.65. Okay, so the correct answer is B. All right, let's ask ChatGPT. Okay. Okay. Question 9. So we expect B. Let's see. It actually went through the math and figured out that the answer B is the correct one. Jesus. Okay. All right. Question 10. The graph shows how the acceleration A varies with time t for a particle undergoing a simple harmonic motion. Okay. Which of the following graphs shows how the velocity V varies with t over the same time interval? All right. This is another great this is another great question because there is no text, so ChatGPT has to figure out the answer just by seeing images. So anyway, so option A is obviously wrong because it's just the acceleration again. And then option C is also wrong because that's the displacement. Remember that A is minus omega squared x. So x is the opposite of the acceleration. So this is the displacement. So the only possible answers are B and D. Can you guess which one is the right one? Let's, okay, let me think. Wait, now I'm confused. I think the correct answer is, okay, at 0 time. The correct answer should be D, okay? Because, to figure this out, wait. I'm sorry. No. I made a mistake, okay? I'm a human being, not an AI. So let me think. If, if this is A, if this is the acceleration, the displacement is, as I said, is this one, C, okay? So the slope, at time 0, the slope of the displacement curve gives you the velocity, okay? So the correct answer is, actually, let me use green here because we reserved red for ChatGPT. Okay, so since the displacement looks like this, then the velocity should start at should be negative at 0 time because this is a negative slope. So B is the correct answer. I hope I didn't confuse you. I'm sorry, guys. Even humans make mistakes. Machines don't, as is the claim. Okay, let's test the machine now. So I'm gonna zoom out so I can take the screenshot. Okay, so because it's a whole page. All right, let's throw it in. So this is question 10. All right. Okay. Okay, the formulas are correct. Acceleration A and displacement x are in phase but opposite in sign. Velocity is 90 degrees out of phase with acceleration. That makes sense, yeah. That's another way to think about it. So, okay. The velocity graph should be a sine, cosine, okay, blah, blah, blah. So, okay, it got it wrong. It got it wrong. Okay, this I didn't expect, to be honest. Okay, and let me show you, actually, I have the mark scheme open here. So for 10, B is the correct answer. Now I'm in shock because I expected it to be correct. So, okay, ChatGPT lost its first point against me. That's great. And it also knows that there is a section B. That's crazy. But wait, let me see. Why did it get it wrong? This graph correctly represents the velocity. Okay. Okay. Okay, we gave it the whole problem, right? Yeah, I mean, everything is there. Okay. Okay. The velocity graph should, if acceleration is a cosine, velocity is a sine, or vice versa. But acceleration is a sine. So look at the original acceleration graph starts at the positive max at t equal to 0. No, it doesn't start like that. Mass start at 0 but rising. Okay, it kind of assumed that that the acceleration starts like that, I think. Anyway, yeah, this is sad, but ChatGPT got it wrong. So not a PhD level model yet. Sorry, guys at OpenAI. Sorry. Okay, let's go to section B now. So, okay, again, here I have my solutions, my handwritten solutions, human written solutions. Okay, by the way, I have nothing against AI. I actually like it and I use it in multiple projects I work on, etc. So if it comes across that I'm trying to compete with it, etc., no, I'm just curious to see what's going to happen. So section B, the water in a swimming pool at the Olympic Games should be at a temperature of 28 degrees. A pool contains 2,750 cubic meters of water at 16.5 degrees Celsius. Calculate the increase in internal energy delta E of the water when it is heated to 28 degrees Celsius. They give you the density of water and the specific heat capacity of water. So this is a simple application of delta E equals to the specific heat capacity of water times the mass times delta theta, okay, the temperature difference. Okay, C is 4,190 joules over kilograms over degrees Kelvin. And then the mass is not given to us, but we are going to use, they give us the density of water, okay, so 998 cubic meters, kilograms per cubic meter, and they give us the volume, okay, so the volume is 27 times 50. Oops, what am I saying? I don't know, I lost my mind. So 2,750, okay, times 11.5, which is the difference in temperature. And this is just rho times V, okay, the density of water times the volume gives you the mass, because the density of a material is equal to its mass over its volume, okay? And delta theta, in general, when you work with heat and thermodynamics and kinetic energy of gases and stuff like that, you have to convert, like if it's 11 degrees Celsius, you have to convert to 283 Kelvin, okay? But here you are lucky, because if you take the difference delta theta between two temperatures, that 273, remember that 0 degrees Celsius is 273 Kelvin. But if you take a temperature difference, you subtract 273 from 273. So using delta theta in Celsius also works, okay? But that's only for this kind of problem. So if you work out the units, you get 1.32 times 10. Oops. Again, I'm making a huge effort to improve my handwriting. 1.32 times 10 to the 11 joules. Okay. And okay, let's solve it all. Let's also do part B and then go to ChatGPT. So B, a heater is used to increase the temperature of the water. Okay. State why the amount of energy supplied by the heater will be different from the value of delta E calculated in A. And this is simply because you're going to lose heat to the surroundings, right? So heat is lost to the surroundings. Okay, let's check the mark scheme. I forgot to tell you that I also have the mark scheme here with me, just to test things. Okay, so to get the full marks, you need to use the density definition, delta E, and find the energy they give you. Okay, and for part B, energy is transfer from the water to the surroundings. Not all of the energy from the heater is used to raise the water temperature. Okay. Do not accept vague statements such as energy is lost. Allow energy is lost to surroundings. Okay, so we are safe. So we got the point. Allow heat for energy. Okay, that's good. All right, the moment of truth. We go back to our friend ChatGPT. Okay, and we need to screenshot the whole page. Okay, and let's throw it in. Okay, this is question 11, the first question of section B. And remember, guys, it already lost 1 point. So let's see how it does with this kind of problems where you need to provide some reasoning and do some numerical calculations and so on. So let's see. Let's see. So calculate the increase in internal energy delta E. Okay, it lists all the things we know about this problem. Step 1, find the mass of water. Okay, that's a really great first step. Step 2, find the temperature change. By the way, what you see there is, I don't know why it's formatted like that. I guess it's a mistake of the output. But that's something called LaTeX, guys. Okay, so let me show you. So LaTeX. Okay, let's go to Wikipedia. So LaTeX is a software system for typesetting documents based on TeX. LaTeX provides a high-level descriptive markup language. Anyway, it's a language used to write mathematics and stuff like that. So you see how they write E equals to mc squared here. Let me find the line. Yeah, this line, okay, allows you to write, when you type this, it's like, LaTeX is, how is it called again formally? Type, it's a markup language. Yes, that's the correct definition. So this is the markup of LaTeX, okay? And it appears, so if you put that subscript and then a letter, it creates a subscript. So E naught equals mc squared. So anyway, so this is what they show here. Anyway, so it found the mass, it found the answer correctly. Wow, okay. And part B, why will the energies applied by the heater be different? Not all energy from the heater goes into heating the water. Some energy is lost to the surroundings, okay? Lost to the surroundings, so the amount of heat. Wow, okay, full marks, okay. So let's put a tick. So let's move on. Question 12 includes, okay, multiple sub questions. So, all right, let me collect myself. So the escape velocity is the minimum speed needed for an object to escape from the gravitational field of a planet. An object traveling at the escape velocity has a kinetic energy equal to the magnitude of its gravitational potential energy at the surface of the planet. Show that the escape velocity v for a planet of mass m and radius r is given by the expression, and they give you the expression. So basically what the problem says is that, let me see, the kinetic energy, okay, is equal to the magnitude of its gravitational potential energy. So the kinetic energy is 1/2 mv squared, and the gravitational potential energy is simply g times the mass of the planet times the mass of the object over r. Okay, and let's see, I'm not sure whether they give you this in the back of the paper, so let's go to, okay, let me see. Okay, unit 5, gravitational field strength, okay, gravitational field force, gravitational potential. Okay, this is what I'm using because for this problem we need the gravitational potential energy, okay, and the gravitational potential energy of an object of mass m in a gravitational potential is equal to m times v. So g m over r. Okay, the negative sign is needed when you talk about the gravitational potential, but we don't need it here because we need the absolute value pretty much. Okay, let's go back. Where was it? Here. Okay, So the mass cancels, and we get that V is equal to 2 times G times the mass of the planet over R, and this is a square root. Okay. B part I. All right. Show that the escape velocity for a mass at the Earth's surface is about 1.1 times 10 to the 4 meters per second, and they give you the mass of the Earth and the radius. Okay, so you just plug in pretty much. So V, I'm gonna provide the answer because, okay, I just don't want to waste time. So 1.12 times 10 to the 4 meters per second, where you just plug in the mass over there and the radius over there, and G is 6.67 times 10 to the negative 11, something like that. Let me see. So that's G. Okay. All right. Let's go back. Okay, and we found 1.12 times 10 to the 4, which is very close to 1.1, so we move on. Okay, part 2. When the Earth formed, a large proportion of the gas in the Earth's atmosphere was hydrogen. Explain why hydrogen gas is no longer a large proportion of the gas in the Earth's atmosphere. No further calculation is necessary. And they give us that at 20 degrees Celsius, the root mean square velocity of hydrogen is 1,900 meters per second, which is 1.9 times 10 to the 3 meters per second. Okay, that's lower than the escape velocity. So let's try to answer this. So the average, okay, actually let's just start by saying that the root mean square speed of hydrogen is 1.9 times 10 to the 3 meters per second, which is less than the escape velocity at 1.1 times 10 to the 4 meters per second. Okay, but according to the Maxwell-Boltzmann distribution, some molecules / atoms, okay, will have velocities higher than 1.1 times 10 to the 4 meters per second towards the tail of the distribution, and thus after billions of years hydrogen gradually escaped. And the distribution looks like this. Let me remind you, this is the Maxwell-Boltzmann distribution. So this is the 1,900 meters per second. So that's the velocity in meters per second, okay? And this is just the number of molecules, okay? So this is the average. So the distribution will look like this. So what we just said is that there will be a proportion of molecules that will have, maybe this is 1.1 times 10 to the 4 meters per second. So there will be molecules that will have velocities higher than that, okay, towards the tail of the distribution, okay? And thus gradually the hydrogen will escape. And by the way, this is the reason why Mars, that has a lower escape velocity, has no atmosphere because all the molecules had enough energy to escape gradually. Okay, so that's something to think about. Okay, let us now see what kind of answers we will get for question 12, okay, from ChatGPT. So let's screenshot this, throw it in there, and then also we need to go to the back and screenshot the last question, okay. And okay, hi ChatGPT, here is question 12 in 2 screenshots. Okay, let's press enter and let's go. Okay, this is the mark scheme. Okay, let's see what we will get for question 12. Okay, show that the escape velocity, blah, blah, blah. The gravitational potential energy is that with the negative sign, as we said. The energy required, okay, they said this, it sets everything, sorry, the kinetic energy equal to the gravitational potential energy, and it correctly solves for the escape velocity. So, as we see here, we get, sorry, let me use red again, we get full marks. Okay, great. Now, does it do the math correctly? Okay, it uses a correct G, the mass of the Earth, the radius, blah, 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 it plugs in, and it works it out correctly like we did. Okay, great. So full marks there. Okay, now let's see what it gets for the second part. Why is hydrogen gas no longer a large proportion of Earth's atmosphere? The root mean squared speed of hydrogen at 20 degrees is that, okay? This is a significant fraction of the Earth's escape velocity, okay? Many hydrogen molecules have speeds close to or exceeding the escape velocity due to the Maxwell-Boltzmann distribution. Okay, we said that. Over time, these molecules escape Earth's gravitational pull into space. Thus, hydrogen gas has gradually been lost from the atmosphere. Okay, that's spot on, actually. Okay, that's great. Let's go back to this. So again, ChatGPT did not disappoint and got 6 marks on question 12. Okay, moving on to question 13. Okay, let me set my notes ready for question 13. All right. The following statement appears on a website. Messier 87 or Messier, I don't know how it's pronounced, is 55 million light years from Earth. The spectrum of light from M87 includes an absorption line at the wavelength of 394 nanometers. The same line produced by a source on Earth has a length of 393. So that's it seems to be redshift. Okay, a light year is the distance traveled in a year by light in vacuum. Assess the accuracy of the statement made on the website. Wait, what's the statement? The following, the statement is that it's 55 million light years from Earth. Okay, and they give us the Hubble constant. So we need to find the velocity of the galaxy, pretty much, to test whether the shift. Okay, I know how to. Okay, so we need to find. Let me write things down. So, need to find V galaxy, which is h naught times d, and see whether that velocity actually produces this shift for the line, pretty much. Okay, so d, the distance, is 55 light years, so 55, million light years, so 55 times 10 to the 6 times 3 times 10 to the 8, okay, which is the speed of light in meters per second, and then we have to use the year in seconds, which is given to us, okay, so 3.15 times 10 to the 7, okay, and this is equal to 5.2 times 10 to the 23 meters. Okay, so this is the distance in meters. Okay, thus the velocity is going to be h naught, which is given to us as 1.62 times 10 to the negative 18 seconds to the minus 1, okay, times 5.2 times 10 to the 23, okay, and this is equal to 841,995 meters per second, okay, and we can calculate the Doppler factor, so which is V over C, okay, and that's equal to 2.81 times 10 to the negative 3, and it's dimensionless because we are dividing speeds with speeds, okay? So now delta lambda over lambda in the lab should be equal to Z, okay? Let's see, is it? So this is a question mark. So delta lambda over lambda, okay, delta lambda is pretty much 1.1 nanometers. So 1.1 nanometers over the lambda in the lab, which is 393.4 nanometers. Oops. Nanometers. Okay, this cancels. And this is equal to 2.8 times 10 to the negative 3. So the statement is correct, actually. Okay. Statement is correct. All right. Now, will ChatGPT get this right? So this is question 13. Okay. And actually, we need just this part. You don't need to screenshot the whole thing because that's where the question is stated. So let's plug it in. So this is question 13. Thank you for all the help so far. Okay, let's be kind to ChatGPT. Okay. Let's see. It might use a slightly different approach. Okay, so it starts by finding Z, okay, the redshift. Okay, good. Z is okay. It's pretty much what we found. Step 2, find the recession velocity V. Okay, it follows. Okay, this is correct, I think. Let me think. Okay, it uses the redshift to find the velocity. Okay, step 3, use Hubble's law to estimate distance D, which is what we did. Okay, step 4, convert D to light years. Okay, 1 light year distance. Okay, 55 million light years. Step 5, assess the accuracy. The website statement is accurate based on the data and calculating using Hubble's law and the observed redshift. So model answer, okay, they found Z, then the recession velocity. In our case, how did we find it? We find it from the Hubble constant they give us pretty much. In their case, they use the redshift. Okay, that's something you can do, I guess. Okay, I mean, it's a little bit different. Okay, let's see what the mark scheme says and assess whether the ChatGPT will get 5 points. So let's go. So use of delta lambda, okay, we did that. Use of V, okay, this is what we did, but ChatGPT used V equals to the speed of light times this Z factor, which they got from there. Okay, that's wrong, actually, it lost a point. Use S equals to VT. Okay, conversion of D to light years. Okay. Okay, so our approach was correct, I guess. ChatGPT was a little bit different. So yeah, I think it loses. Let me know what you think in the comments, but I give it 4 points, 4 marks. So because it uses that strange approach of finding the recession speed of the galaxy by multiplying with the Z that we found here, pretty much. Sorry, here. So anyway, okay. Now let's take it correct. I think it's correct. It's fine. Okay, it's just that it does things a little bit differently. So anyway, let's move on. Question 14. Let me turn my page. So How many questions are there in this test? I think 20 something, 18. $21. So, 150 grams mass is hung from a vertical spring. The mass is displaced from its equilibrium position and oscillates vertically with simple harmonic motion. The graph shows how the elastic potential energy varies with displacement of the mass from the equilibrium position. Okay. Add a line to the graph to show how the total energy of the mass spring system varies with displacement. Okay, pretty much this is the line. Okay, so the maximum kinetic energy. Okay, that's the total energy. And the reason is because the potential energy will be like this. It will be maximum, something like that. I don't know if it's asked, but that's why. So let me erase this. And actually, I forgot that. Okay, I'm going to erase this as well, because we said that red color is reserved for ChatGPT. So this is the total energy. All right. Okay. Determine the speed of the mass when it's displaced from the equilibrium position. When its displacement from the equilibrium position is 1 centimeter. So let me think. Okay, so let me use black. I'm sorry. So the elastic energy plus the kinetic energy is equal to the total energy. Okay, so the kinetic energy will be equal to the total energy minus the elastic energy. Okay. Wait, earlier I told you that this is the elastic energy, I think. Okay, I don't remember, but this is the kinetic energy. I'm sorry. So anyway, okay. So what I'm trying to do here is that we want to find the velocity when the elastic energy is this one, pretty much. Okay, so the displacement is 1 centimeter. So okay, the kinetic energy at 1 centimeter is going to be equal to the total energy, which is about 19 millijoules, because this is what is given to us, minus the elastic energy at 1 centimeter, which is the one I indicated here, which is about 4.5. And this is times 10 to the negative 3 joules. Okay, so 1/2 mv squared should be equal to 14.5 times 10 to the negative 3 joules. So the velocity is going to be the square root of 2 times 14.5 times 10 to the negative 3 over 0.15, because 150 grams is 0.15 kilograms, and the answer is 0.44 meters per second. And this is question 14. Okay, let's see the mark scheme. Okay, this is the mark scheme, so we did this correctly. Let's see, this is a tricky question for the AI because it involves looking at the graph. Okay, so I'm curious to see if it will get it right. Okay. Okay, let's throw it in. Hi chat, this is question number 14, right? Okay. All right, the moment of truth. Okay, total mechanical energy in simple harmonic energy is constant and equals the maximum elastic potential energy. Okay, that's correct. On your graph, this is the horizontal line at the highest value of the elastic potential energy when displacement is plus or minus 2 centimeters. Okay, let's go and see this. Okay, that's correct. It actually read correctly the maximum displacement. And the energy, okay, it's not 20, it cannot see it, okay, but the solution is along the right path, pretty much. So draw a straight line, okay, the straight line is a little bit lower actually, but okay, fine. Determine the speed when displacement is 1 centimeter, known quantities, okay. Elastic potential energy at x equals 1 centimeter is about 5. Okay, we said it's 4.5, fine. It plugs in like we did, and it finds something really close. Okay, so let's see. The mark scheme says, for this problem, horizontal line drawn at 19 millijoules. Okay, so it will lose 1 point here. So ChatGPT lost the point again. Okay, so it lost this point, and the elastic potential energy at 1 centimeter read from the graph accept values in the range of 4 to 5 millijoules. So that it got it correct actually. All right, so I guess it lost 1 point. Okay, so let's give it 4. So 4 marks. All right, moving on. Question 15. Cesium-137 is a common product of uranium fission. Very small samples of cesium-137 can be used to calibrate radiation detector equipment. Cesium-137 decays to an isotope of barium by emitting a beta minus particle. Complete the nuclear equation for the decay of cesium-137. All right. For some reason, I don't know. Let me fix my solution. So, all right. So the beta particle has a mass number of 0 and a proton number of -1. Okay, the charge is -1, right? And this is 137 because it has to match the left-hand side, and therefore this is 55. Okay, that's the first question. Part B. A sample of pure cesium-137 has an activity of 7,400 becquerels. Calculate the mass in kilograms of the sample. They give you the half-life, the mass of 137 cesium atom, and 1 year in seconds. So how are we going to work this out? So let's start by stating that the activity is equal to lambda, the decay constant, times the number of nuclei. So the number of nuclei in the sample is equal to the activity over lambda. So the activity is 700. And one more step. Lambda is, okay, since they give us the half-life, we also need to use the fact that lambda is equal to ln of 2 over t1 half. Okay, so if we plug that in, we will find activity over ln of 2 times t1 half. Okay, so this gives us 7,400 over ln of 2 times t1 half, which is 30.2 years, and 1 year is 3.15. Oops. Again, my handwriting, I'm sorry guys, times 3.15 times 10 to the 7. All right. So this gives us a pure number, which is the number of nuclei. So 1.02 times 10 to the 13 cesium atoms, okay? Then the mass of the sample is equal to the total number of nuclei, in the sample times the mass of one cesium-137 atom. So 102 times 10 to the 13 times 137 U, and 1 U is 1.66 times 10 to the negative 27 kilograms, as you can see in the back of your paper. And the answer is 2.3 times 10 to the negative 12 kilograms. What does the mark scheme say? It says the same thing. Right. Now, ChatGPT. Okay, let's give it question 15. I'm sorry, guys, this is getting tedious, but we're going to go through it until the end. So, this is question 15. So, will it figure it out? Let's see. Okay, let's check. Okay, it correctly completes the reaction. That's good. Okay, good. And then it goes the other way around. It finds lambda. Okay, it plugs it in there to find the number of nuclei as we did. And it correctly finds the mass. Okay, full marks here. So let's put a tick. Okay, question 16. A recent theory suggests that during the Big Bang, an anti-universe was created alongside our universe. This theory suggests that dark matter is a new type of neutrino particle. Describe what is meant by dark matter. So this is a type of matter that only interacts gravitationally with ordinary matter. Okay, full stop. It accounts for the constant velocity of stars in the outskirts of galaxies. Oops. Of galaxies. And it does not emit. Emit is with a double M, I think. So emit electromagnetic radiation. All right, part B. The theory suggests that the mass of the new type of neutrino particle is 4.8 times 10 to the 8 GeV over c squared. Calculate the mass of this particle in kilograms. Okay, that's not bad of a question, I mean. So the mass is 4.8 times 10 to the 8. And then GeVs, 1 GeV is 10 to the 9 EVs. Then 1 EV is 1.6 times 10 to the negative 19 joules. And then we have to divide with the speed of light, 3 times 10 to the 8 squared. Okay, because we have the square, the c squared over there. And this gives us 8.5 times 10 to the negative 13 kilograms. Part C. The ultimate fate of our universe is uncertain. Explain how the existence of dark matter contributes to this uncertainty. So, a way to answer this is to say the universe is flat, open, or closed. Okay, depending on the total mass it contains. And hence, the total gravitational mass. Okay, dark matter is a piece of this puzzle contributing extra gravitational mass. Okay, let's see what the mark scheme says for this problem. Okay, dark matter has mass. Dark matter exerts a gravitational force. Dark matter does not emit electromagnetic radiation. We wrote all this. Okay, our answer is wrong. Wait, I did something wrong. Wait, that's not wrong. The mark scheme is wrong because this should be 19, not -1. I don't know. Something's wrong with this problem. Let me go back. Sorry. So 4.8 times 10 to the 8 GeVs, which is 10 to the 9 times 1.6 times 10 to the negative 19 over 3 times 10 to the 8 squared. Let me check my calculation again real quick. I'm sorry. Because the mark scheme, I don't know, something's wrong with the mark scheme or with my calculation actually. Okay, over 3 times 10 to the 8 squared. It's sorry, it's my fault. Okay, so this is the first time I'm defeated by machines. I wrote 13, it should be 19. For some reason, in my notes, I have -13 instead of -19. So this part was correct, okay? I just messed up the calculation. All right. Now, ChatGPT time. All right, so let's take the screenshot as we do, throw it in there, and tell it it's question 16. All right. Okay, part A. Dark matter is a type of matter that does not emit, absorb, or reflect electromagnetic radiation, so it cannot be observed directly by telescopes. Its existence is inferred from its gravitational effects on visible matter, such as the rotation curves of galaxies and the motion of galaxy clusters. That's correct. Okay, it calculates the mass correctly. And in part C, the ultimate fate of the universe depends on its total mass and energy density, which determines whether it will expand forever, stop expanding, or eventually collapse. Because dark matter's total amount and properties are not fully known, we cannot precisely determine the universe's total mass, making predictions about its fate uncertain, which is correct. Okay, great. Okay, question 17, part A. All right. A scuba tank is used to store air at high pressure. A diver breathes underwater, a diver, not a driver, I'm sorry, breathes underwater using air from the scuba tank. A scuba tank contains air at a pressure of 1.28 times 10 to the 7 and a temperature of 17.5 Celsius. The scuba tank is left outside on a sunny day and the temperature of the air inside the scuba tank increases to 42.5 degrees Celsius. The volume of the scuba tank remains constant. Okay, makes sense. Calculate the increase in the pressure exerted by the air inside the scuba tank. Okay, so let's write the ideal gas law. So the initial pressure times the initial volume is equal to N times K times the initial temperature. And also the final pressure times the final volume is equal to N times K times the final temperature. Let's divide these two, recognizing that the initial and final volumes are the same, the number of molecules is the same, K is the same. So Pi over Pf is Ti over Tf, right? So the final pressure that we are looking to find is Tf over Ti times Pi, okay? What's Tf? Remember, you have to convert to to Kelvin. So 273 plus 42.5 over 273 plus 17.5 times the pressure, which is 1.28 times 10 to the 7, gives 1.39 times 10 to the 7 pascals for the final pressure. So delta P is, if we subtract from the initial pressure, 0.11 times 10 to the 7 pascals, which is the increase in pressure. Okay. Part B, explain why the pressure of the air inside the scuba tank increases as the temperature increases. your answer should refer to the motion of the air molecules. So if temperature increases, then the average kinetic energy also increases, and since 1/2 m times the mean squared velocity is equal to 3/2 kt, then so the speed increases. Okay, so since the velocity increases, okay, both the frequency of collisions and the frequency of collisions with the wall, not the well, with the wall, and the intensity increases. Okay, there is more momentum transfer. Okay, more momentum transfer to the walls. Okay, hence more force, hence more pressure. Okay, and let's check the mark scheme really quick. This is question 17. Delta P is 1.1 times 10 to the 6, which is what we found. If we go back, okay, 0.11 times 10 to the 7 is the same as 1.1 times 10 to the 6. Okay, and for the long writing problem, we have to include as the temperature increases, the average kinetic energy of the air molecules increases, mean average speed of the molecules increases, mean change in momentum of air molecules when colliding with the wall increases, rate of collisions increases, the rate of change of momentum increases, the pressure increases. Okay, we included all points. Let's see if ChatGPT will do the same. So let's take this screenshot for the first part and throw it in there. Okay, and let's do part B. Okay, throw it in there. Okay, this is okay. Let's thanks ChatGPT. Thanks ChatGPT. The question 17 has 2 parts attached in the 2 screenshots. Okay, let's see. Will it get it correct? Okay, part A, it calculates things and it's spot on the increase of pressure. Okay, for part B, as the temperature increases, the average kinetic energy of the air molecules increases. Correct. Molecules have move faster and collide with the walls of the tank more frequently and with greater momentum. That's correct. Each collision exerts a greater force on the walls. Correct. Since the volume of the tank is constant and the number of molecules does not change, this increase in force per unit area causes the pressure to rise. Okay, that's spot on. Wow. Okay. I guess I have to quit being a physicist because ChatGPT does as well as I do so far. Okay, problem 18. In the 16th century, the astronomer Tycho Brahe made measurements of stars in the night sky. Those of you who are German speakers, please let me know if the pronunciation of the name is correct. He measured the angle of a range of stars above the horizon. For each star, he measured the angle the angle over a period of time to determine a parallax effect. I describe how stellar parallax is used by astronomers. Okay, so I'm gonna use a clean page for this. So this is the sun. Okay, this is the sun. and this is the Earth, which is a point compared to the Sun. All right, then this distance is 1 astronomical unit, okay? And the same goes for this distance, of course, okay? And these two extreme positions are summer and winter, for example, or spring and autumn, okay? So they have to be 6 months apart, all right? So let's say that there is a background of stars that are so far away, maybe over here, okay? So these are the background stars. I'm sorry I'm using red. Actually, yeah, we agreed that this is the ChatGPT color. So let's use orange. So these are the distant stars. So distant stars that don't move in the night sky, okay? All right, and these are some, maybe this is a star over here, much closer, okay, compared to the distant stars. And okay, when we observe this star from here, okay, we will see, okay, these are the stars, okay? If we extend this line, we will observe those stars behind the star under examination, okay? But if we measure the same star 6 months later, due to parallax, okay, we will see the star having these stars behind it, okay? So that's the idea. This is an extreme idea, by the way. I mean, this is an extreme case, but I just want you to understand. Okay, so this is the angle theta, the parallax angle, as it's called. So the question asks to describe how stellar parallax is used by astronomers. Okay, so okay, let's write down a few things. So observe the star against the background, against, let's call it BG, a background of distant stars within a 6 month, I'm sorry, oops, a 6 month interval, okay? Measure the angle, the parallax angle, I mean, okay? Measure the parallax angle, so this one, the theta, okay? Okay, let's, I need one more extra page. So, since, why did it, yeah, accidentally I pressed a different template. So anyway, let's say we're gonna work with this. So since the distance between the Earth and the Sun is 1 AU, use trigonometry, okay, to find the distance of the star. In other words, sine theta, I mean, you can see it from the scheme here. So sine theta is 1 AU over the distance d. So if this is d, the distance of the distant star we want to find, we just use basic trigonometry. Okay. Question A, part 2. Tycho Brahe concluded that the Earth was motionless at the center of the universe as he was not able to detect any stellar parallax. Suggest why he was not able to detect any stellar parallax. So maybe it's because the stars were too far away. So that's a plausible reason. So let's switch to black. So stars were very far away, so there was no parallax. Okay. Okay, part B. Tycho Brahe was one of the few astronomers to observe a supernova. Supernovas are used as a type of standard candle. State what is meant by a standard candle. So, standard candles. Okay, I promised I'm gonna make a better handwriting. So, standard candles, okay, have a known luminosity. Okay, so you can use the fact that the intensity of radiation you receive here on Earth is equal to that luminosity that you already know over 4 pi d squared, which is the radiation law. So you can find d easily, okay? Describe how standard candles can be used to determine the distance to nearby galaxies. So we already answered this. So first you need to find a standard candle. Find a standard candle. Okay. Second part is to measure the intensity. Measure its intensity of radiation on Earth. And then use the fact that the intensity is equal to the luminosity that you already know over 4 pi d squared to calculate the distance. Okay, this was a kind of an easy problem, just a description for 9 marks. All right, let's see if ChatGPT will get it right. Okay, can we zoom out and capture all of it? Let's see. Okay, yes. Okay, I think ChatGPT will be able to read it. All right, so let's see. This is question 18. Let's see. Describe how stellar parallax is used by astronomers. Stellar parallax is the apparent shift in the position of a nearby star against the background of distant stars when viewed from different positions of the Earth in its orbit around the Sun. Astronomers observe a star from 2 positions 6 months apart, correct? They measure the angle of its apparent shift. Using trigonometry, the distance to the star can be calculated because the baseline distance between the two observing positions is 2 astronomical units, and the parallax angle are known. Okay, that's correct. Suggest why Tycho Brahe was not able to detect any stellar parallax. The stars are so far away that their parallax angles are extremely small, too small to be detected with the observational instruments available at that time. Actually, this answer is better than mine, okay, I have to admit. 18b, part 1. What is meant by a standard candle? A standard candle is an astronomical object with a known luminosity. Okay, good. And then part 2. Describe how standard candles can be used. Okay, the apparent intensity of a standard candle as observed from Earth is measured. Since its luminosity is known, the inverse square law for light can be used. Okay, perfect. By comparing the known luminosity to the observed brightness, astronomers calculate the distance to the standard candle and thus to its host galaxy. Perfect. Okay, that's actually the answer. I think it's better than mine, but okay, let me know, guys. All right. Question 19. This is a long paper. Too many questions. So, the suspension system of a car is a set of springs that allows the body of the car to move vertically up and down relative to the wheels. A car is driven along a long straight road and has a series of speed bumps. Okay. Along a straight road that has a series of bumps. Speed bumps are raised parts in the road. As shown, there are many of these in Cyprus, by the way, guys. It's a disaster for the cars. So, at a particular speed of the car, resonance occurs. The amplitude of vibration of the car body on the suspension system becomes much larger. explain why the amplitude of vibration increases at a particular speed. So I guess the reason is that forced oscillation is induced in which the frequency of the force, the force experienced by the wheels, okay, of the driving force, let's call it like that, the driving force, okay, matches the natural. I think maybe my pen ran out of battery. Let me check. Sorry guys, give me a second. Let me think. Because it's not writing easily. I don't know, something's wrong with it. Yeah, I'm running out of battery. Okay, suspected that. So, matches the natural frequency of the spring. Okay. And maximum energy, and thus maximum energy is transferred. All right, part B. When a person of mass 65 kilograms steps into the car, the vertical height of the car above the road decreases by 2.5 centimeters. Resonance occurs when the speed bumps are spaced 25 meters apart. Calculate the speed of the car. The car is driven along the road. You should consider the car as a mass spring system. The mass of the empty car is that. Okay. So first of all, we can find the spring constant by setting mg equal to k times the displacement, because they give us the displacement for a person of 65 kilograms. So k is mg over over x. Okay. So 65 kilograms times 9.81 over 0.025 yields 25,506 newtons over meters for the spring constant. Now the period is equal to 2 pi, right, times the square root of m over k. Okay, so we have to calculate the period for the spring, so we are able to calculate the velocity, right? So that's 2 pi times the square root of we want to calculate the period of oscillation of the whole car, so the mass of the car plus the mass of the person over 25,506 yields 1.45 seconds. Okay, and we are told that the resonance occurs when they are 25 meters apart. Okay, so the resonance occurs when the frequency of the external force is the inverse of this period. So since the distance is equal to u times t from your SWAT equations, basic SWAT equations, then u is s over t. So we are going to substitute t for 1.45 seconds. So 25 over 1.45 yields, let me see, 25 over 1.45 yields 17.2 meters per second, which is equal to 62 kilometers per hour if you convert it. It's a nice exercise. Okay, part C, explain how damping reduces the large amplitude of vibration of the car on its suspension. So pretty much you have to mention that energy is dissipated to the damper. Okay, That's an answer. Okay, let's check the mark scheme real quick. Okay, the car body is driven, force into oscillation as its natural frequency. This is part A. I'm sorry, I didn't mention it. There is a maximum transfer of energy, correct. Okay, the velocity we found is correct because you have to find the spring constant and then the period of oscillation and then the speed. And then for part C, kinetic energy is transferred from the car. The energy is dissipated to the surroundings, so the vibration decreases. Okay, we didn't mention this actually. So the kinetic energy is transferred from the car. Okay, makes sense. All right, let's put ChatGPT to the test. Okay, let me see. Okay, let's take 2 screenshots. Actually, wait, let's make this larger again. Okay. Okay, let's dump that in there and also let's take a screenshot again. Throw it in there. Okay, this is question 19. Thanks so far. Okay, let's see what ChatGPT will come up with. Okay. Okay, part A. Explain why the amplitude of vibration increases when the frequency at which the car encounters speed bumps matches the natural frequency of the car's suspension system. Resonance occurs. At resonance, the energy supplied by each speed bump adds constructively to the oscillation, so the amplitude of vibration increases significantly. Correct. Okay, here it calculates the spring constant correctly. Okay, instead of the period, it actually calculates the frequency, which is fine. Okay, that's not wrong. And then it correctly calculates, using that frequency, it calculates the speed correctly. Okay, perfect. And then for part C, it says that damping dissipates energy from the oscillating system. Good. This reduces the energy added at each cycle and decreases the amplitude of vibration, especially at resonance. Okay, this answer is better than mine, I feel. Okay, let's move on. I forgot the tick marks for ChatGPT. Okay, that's correct. And yeah, we put that earlier. Okay, let's move on. Question 20. In the 18th century, Cavendish carried out the first experiment to determine the gravitational constant G. The experiment used 2 lead spheres. And here I'm going to make a pause and mention that Cavendish is the name of the physics department at Cambridge, if I'm not mistaken. I'm not going to check it. Let me know, guys, if I'm correct or not. So I'm going to know if you watched this far. So, and thank you if you did. Okay. So, and I'm not sure if Cavendish did work at Cambridge. I'm not sure about that. Anyway, so a physicist planned to investigate the gravitational force using lead spheres identical to the ones used in Cavendish's original experiment. One of the spheres had a diameter of 30.5 centimeters and a mass of 158 kilograms. The second had a diameter of 2.5 centimeters and a mass of 0.73 kilograms. The minimum force that will be measured by the physicist was 50 micronewtons. Deduce whether the physicist will be able to measure the gravitational force between the 2 spheres. Okay, let's, okay, we know the diameter, so we can divide by 2 and find the radii. Okay, so let me think. So pretty much this is the situation. Okay, let me draw the scheme because I got myself a little bit confused. So this is D1, and let's say that this is D2. Okay, so the distance R between these two guys, R, is D1 over 2 plus D2 over 2 because we're given the diameters. And that's, okay, 33 over 2 is 16.5 centimeters, which is 0.165 meters. Okay, so the force is G M1 m2 over r squared. So 6.67 times 10 to the negative 11 times 158 kilograms times 0.73 for the second mass over 0.165 squared yields 28.3 micronewtons, which is within the range. So the minimum force that could be measured, the minimum force that could be measured by the physicist was 50 micronewtons. So it's not possible actually, right? Wait, I'm confused now. Okay, so okay, what does the mark? Now I'm really confused. So yeah, it cannot be measured. Yeah. So okay, yeah, that's the answer. For some reason, in my solution, I said it's possible, but since 28.3 is less than 50, it's not possible. Okay. Part B. Experiments to determine G have usually been carried out using large masses. In 2021, physicists at the University of Vienna carried out an experiment to determine G using gold spheres with masses of less than 100 milligrams. They obtained a value of G equal to 604 times 10 to the negative 11 meters cubed kilograms over second squared. Show that meters cubed kilograms to the -1 seconds to the -2 is a correct unit for G. Okay, so force is G m1 m2 over r squared. Okay, so G is let me actually so the units for force must equal the units for G times the units for m1, units for m2 over the units of r squared, and the square brackets means the units, okay, as I described. So force is measured in newtons is equal to the units for G times kilograms squared over meters squared, but then 1 newton is a kilogram times meters over second squared, and this is equal to G times kilograms squared over meters squared. Okay, so the kilograms cancel, so I need a clean page. So the units for G end up being meters cubed kilograms to the -1 times seconds to the -2, and that's the answer. And second part, the physicists concluded that their value for G was within reasonable agreement with the standard value of G. Evaluate the validity of this statement. Okay, so the G they calculated minus the actual G over the actual G is times 100 is, if you do the calculation, because it's been a long time since we are doing this video, so the difference is 9.45%, which is too large of a difference. Okay, which is too large. Okay, let's test ChatGPT on the next question. So let's do it in two parts, two screenshots. So the first one and the second one. Okay, I feel like this is gonna be a really long video, sorry guys. So this is the next question. Okay, so my pen is running out of battery. Let me see if I can do something. So okay, give me a second, because I'm trying to plug my pen in so it gets a little bit of charge until we examine the answer of ChatGPT. All right, so All right. Part A, find the gravitational force between the spheres. Okay, let me see. Gravitational force between the spheres. It finds it to be 28.3 micronewtons. Okay. All right. It doesn't answer though whether it's possible or not. Oh, no, it does. Compared to minimum measurable force. Yes, the physicists will be able to measure the gravitational force because the calculated force is much greater than the minimum measurable. Wait a second, I made a mistake here. I just realized, okay, so actually the answer should be, okay, let's check the mark scheme. Maximum force is 28.3 micronewtons. Okay. So it can't be measured. Okay, so this is a case again. Okay. No, my answer is correct. See how AI can fool you. So actually, ChatGPT is wrong because the correct answer is 28.3 micronewtons and not 280 micronewtons. So in this case, ChatGPT is wrong. So part A is wrong, and I'm really happy to put a cross here and say that it was wrong. Okay, part B, rearrange for G, which is what we did. Okay, that's correct. And the second part, it finds the difference to 9.5% like ours. So this is fairly large. The difference is significant and may indicate systematic error. Okay, so in this problem, ChatGPT just gets 4 marks because it's wrong. Okay, next question. And I think last, okay? Let me see. Yes, it's the last question. The planet Captain B, I don't know, whatever, orbits Captain Star. Scientists think the conditions on Captain, I don't know, B, could enable the long-term survival of humans. Okay, the spectrum of radiation emitted by Captain Star has a peak of intensity at the wavelength of that, show that the surface temperature of Captain Star is about 3600 degrees Kelvin. Okay, let's try to work this out. So for this one, we just need Wien's law. So lambda times T is 2.898. Sorry, my pen is running out of battery. Times 10 to the negative 3. So the temperature is 3569 Kelvin. So okay, that's correct. Then the distance from Captain's Star to the planet Captain B is 2.55 times 10 to the 10 meters. Okay, let me check something real quick. So I think I'm trying to do something with my pen because it doesn't have battery. So you run into technical difficulties when making videos, guys. I'm sorry. So the intensity IE of light received at the Earth from the Sun is 1380 watts per square meter. Show that the intensity of radiation received at Captain B from Captain Star is about 0.4 IE. And they give you the radius of Captain Star. Okay, this allows us to calculate. Okay, so let's do a few calculations. So L is sigma A T to the fourth, and then the intensity of radiation is L over 4 pi D squared. So If we plug L into there, we find sigma and then 4 pi times the radius of captain squared, okay, times the temperature of captain to the fourth over, okay, 4 pi, and the 4 pi's cancel, times the distance squared. And if we plug everything in, we find 583 watts per square meter. So if we divide the intensity from captain from the intensity at the earth, we find 0.42, which is about 0.4. So that's correct. I mean, the statement there. Okay. And finally, the last question. This has been a long paper, guys. I'm sorry. I didn't expect this to drag for so long, but okay, it's because we were using also ChatGPT. So humans will not be able to survive on a planet with a gravitational field strength 4 times greater than the gravitational field strength at the surface of the Earth. Deduce whether humans could survive the gravitational field strength at the surface of Captain B. They give us the radius and the density. Okay, so G is the gravitational constant times m over r squared. Okay, and also the density is equal to mass times volume, right? So if we combine these two, G is 6.67. My pen is not writing, guys. It's not my fault, okay? To the minus 11 times 6.44 times 10 to the 3, which is the density, times, I'm going to multiply over here, the volume cubed, which is 4/3 pi times the radius of captain, whatever, 1.02 times 10 to the 7 cubed, okay, over this whole thing has to be divided by the radius squared, by 102 times 10 to the 7 squared, and this gives us 18.37 newtons per kilogram, which is, which equals 1.87 G on Earth. So it's livable, okay? And that's the answer, and it's time to test, to put ChatGPT to its last test. It did great, guys. I mean, it lost some questions, but overall it did excellent. I didn't expect it to be so good. Okay, so let's split this into 2 screenshots, throw them in there. So this is the last question. Thanks for all. Okay. Okay. It calculates the temperature correctly. It uses the correct formulas. Okay. Blah, 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 blah. I don't know why it takes it. Okay. It overcomplicated things. But eventually it used the same formula as we did to find 0.4. Okay, it worked. And last but not least, okay, it calculates the mass using the density, plugs into gm over r squared, finds 18.4 like us, 1 point. So this is less than 4 times Earth's gravity. Conclusion, humans could survive the gravity of Captain B as it is less than 4 times that of Earth's gravity. And this is it, guys. Thank you to all of you who stayed this long. This was an unusual walkthrough, Unit 5, an unusual walkthrough the Unit 5 test from, what was it, January, I think, 2023? Yes, okay. And we also tested ChatGPT And the final verdict is that it lost 1 mark from the first part, okay? 4 marks from question 20. And in general, it just lost, it didn't get all full points. It got like, these tests are out of 90, so it lost about 7 marks. So it got an 83 out of 90. So that will be an A star probably. So I don't know. Let me know in the comments. And anyway, this was it. Thank you again for those of you who are following me, and see you in the next one.